All right, here is the first video in documenting the process of making a game. This will be hopefully the first game that I've actually completed. I've made a bunch of small little projects that haven't really gone anywhere. This one feels like it has some momentum behind it. So I'm going to go ahead and build it and then run it real quick. What I have is a very basic prototype of just some visuals and some audio, where we're going to see how this all works. And folks, it just doesn't get any better than that. That's the game right now. Okay, so what the hell is that? So it's going to be sort of a dialogue-focused. I don't think you would call it an RPG, because I don't really plan on implementing any sort of progression mechanics or leveling or skills or anything like that. It's more of an exploration, going around and talking to people, finding items, and yeah. So what you just saw there was this little block of animated text and a little character portrait underneath. This is all being rendered with the SoCal library, which, if you don't know, is basically a collection of single header libraries written in C for doing desktop applications, graphics, and I'm also using it for audio in this case. So I'm going to go over a little bit of that, how that's all sort of working under the hood so far. Nothing too complicated, because as you saw, I mean, you know, I'd say the game is about 75% complete. But you know, there's a couple of things to be done here and there, a couple of things to iron out. I wrote pretty much all this on Linux, and now I ported it to macOS like an hour ago, which is pretty easy to do with SoCal, although there are a couple hiccups and a couple weird things going on, which don't really need to get into right now. But so basically how the game is working, we call this is our main function right here. We call this function called memory init, which this is basically just doing arena allocation. I have like a little code base I've written in C that has some basic sort of helper stuff and utilities that you would kind of want anywhere. So there's an arena allocator, as well as like a string library and stuff for working with the file system and stuff like that. But the arena allocator in this case, we provide it with a couple statically allocated heaps. You can see here we have this thing that I call a G heap, which is sort of like a global heap or something, and that is a 64 meg block of memory, and that's going to form the entire block of memory that the game is going to occupy. We allocate all of that up front, and then we just sort of provide that as a backing buffer to the arena. The arena itself lives in that buffer, and it has this sort of like a virtual memory style API that you know, I've taken from like the RAD debugger code base. But in this case, what that API also allows you to do is to provide like an optional backing buffer, and so you can like statically just allocate like an array of bytes like this and use that as the backing memory for the arena. So that's what I'm doing for this global heap, and then we also have a frame heap or a frame arena, which is 64K, and these sizes are of course subject to change. We'll see how quickly I run into those limits. I'm not currently overriding any of the allocations that SoCal is doing, which I probably want to, just for the pathological need for complete autonomy that I have, which is why I'm doing all of this in C and writing all my own utilities aside from the rendering library and stuff like that, which I also considered doing from scratch, but you got to draw a line somewhere. So yeah, this is just our memory allocation API. You init the two allocators that we have, and then at the end of the program, it gets de-initted, which really just, let's see here. When you call arena de-init, like that would just release whatever memory is, which, to be fair, we shouldn't be doing here because all of it's statically allocated. So this actually never needs to be called. Yeah, this function kind of shouldn't exist. So whatever. And then really all we have on top of that for allocating memory is push struct, which just allocates, you provide it with type, allocates type size of bytes, and then there's push array, which allocates an array of stuff. Okay. So yeah, there's our memory API, and then we initialize some audio, which is just using the so-called audio library. And so there's just kind of simple audio system we have right now. Just using some global state because I'm not using the callback method. So so-called audio allows you to do something where you could provide it with a something like audio callback or stream callback or something. They call it something like that, and what that would be is you would write a function where you get a buffer. You get called back at this function where you get a buffer input with a certain number of frames, which is, samples times the number of channels, and then it also tells you how many channels you have, and then you would just sort of, process all your audio. You just sort of write directly to this buffer. And that would all happen on its own thread, which is probably not a bad idea to sort of minimize the amount of overhead you're incurring, but if you're processing audio on the main thread. But I would rather queue up audio events in a kind of single-threaded way, at least for this very simple game project. So yeah, we just do some setup here. We have a master volume that will eventually be, you'll be able to set this from kind of anywhere in the program. And then something I want to do down the road is something to push a volume where we would probably maintain some kind of a volume stack, Excuse me. I just had a lot of butter. So you'd have a volume stack or something, right? And so you'd have a head on that. Say you're somewhere in the gameplay code, and something happens where we want to modify the volume of a certain set of sound effects, and it's going to be maybe a few of them, we don't know, but it's you want to say, hey, everything after this point is going to be, we want to push a volume, we want to set it to, you'd probably want to express this in decibels, but for let's say for now we just know, okay, we want it to be 25% full scale, 25% of full scale, which is still kind of loud. That's minus 12 dB or something like that. And so what this function would do is just push that volume onto the stack, and then in our audio rendering, you would eventually have like, some concept of like DQing like incoming effects, and then you would apply whatever's at the head. Your current like audio sample would get multiplied by whatever is at the where it wouldn't be the head, but it would be the last thing pushed on the head. Anyway, that's not implemented yet, but it's just kind of a fun idea I had today. What was an interesting thing to get going was working with like a dialogue sound and controlling when this sound is actually playing, because you want it to be timed up with like when the text is actually rendering on the screen. So if we go back and look at this quote unquote game, it sort of does the thing, and it's a little rough and probably a little too loud, but it sort of does the thing where there's like this kind of quote unquote typewriter sound. And so how that works is there's a couple things. So in our game update and render function, we have this draw function, which does some stuff. We set up projection matrix so we can do our coordinates in terms of screen space for now. And then we have this draw dialog box function. And this sort of draws that frame around the dialogue and around the character portrait. One thing that we have here is this whole animated text thing. So text is easy enough to do on its own. I'm using the so-called debug text library for the time being, because it's an easy way to kind of get started. That may end up getting replaced with something a little more robust that I can have a little more control over how the API works, because it is a little janky. It's more meant for kind of just like quick debug text, which is why it's called debug text. We have a draw character function. We have a draw text function. And then we have this draw text wrapping function, which will take an unwrapped, long line of text and wrap it to a certain line width. And this went through a couple iterations of trying to figure out like how it actually should work with the animation, which kind of got added on after the fact. So that is animated text. How that works is we create this struct, and the way it works now, so we just statically allocate an animated text struct just kind of here, just in a random spot, and then in the draw dialog box function, when we first initialize the game, like on our first frame, we set up this animated text, because I don't yet have like an interactive dialogue system. But we call animated text init, and that it takes a string, and then it takes a parameter which is characters per second. And so that's kind of like the speed at which the text is going to sort of scroll out. So what I have right now is 30 characters a second, which is what we just saw is like, that's the speed at which it scrolls out, is about 30 characters a second. So that calls push dialogue sound. And so we go back to this audio thing here. Push dialogue sound, we'll take in those parameters and we'll kind of fill in some details about whether that sound should be playing. The frequency, which is it's basically just a sine wave at a certain frequency. And so you notice over here in push dialogue sound, we call 232 hertz is the frequency of that sine wave, and then 30 is that's our characters per, oh wait, I should probably that shouldn't be 30, but that should be characters per second, because we want that that actually controls the oscillation of the volume of the sine wave. That's tied into the speed at which the text is animating, and the idea there is that, like, for each character that comes out, you want a little sort of burst. You want that sine wave to come on and then to shut off, sort of in between characters. And I don't know if that timing actually works out quite the way, if it's exactly 1-to-1, because a 30 hertz oscillation is going to be off. The positive side of that oscillation will be the waveform coming on, but 30 hertz is 30 cycles, so that's 30 pairs of on-off. And what we really want is, you almost want 60, right? Because you want it to go on with the character and then off. Or do you want half? I think you want half of what the characters per second is. I'm just kind of curious if that looks better. So if we build that, that sounds interesting. But not quite that. That definitely does not sound like the speed that you would. Okay, and you know what? I preempted myself here, because in push dialog sound, we actually cut the oscillation frequency in half, because we're sort of anticipating that that fact. To me, that looks appropriate. So anyway, we call push dialog sound, and that sets some global state about what kind of frequency and oscillation we should be outputting. So then later on in the frame, this audio render function gets called once per frame. And if there are frames to be filled, then we kind of start crunching some numbers about how to render that audio. And this is all a bunch of frickin' DSP stuff that I'm not going to explain it in too great a detail, but it's basically just sine waves. We generate a sine wave, and then we modulate the volume of the sine wave by that oscillator frequency that we talked about just a second ago with the dialogue, the characters per second and stuff. And so then we write that out to the so-called audio buffer. And then this is just some other stuff if the audio is not playing, actually. So that that gets into, in this animated text thing, we basically iterate character by character, and we step forward, by the delta time, and every time we reach our seconds per character, we wrap the step around an increment by one character, and then eventually, once we reach the full length of the text, we want to, I call this function pop dialog sound, which basically just tells us to stop playing the dialogue sound. And I feel like it's kind of fine for this to be global state in this audio state, because it's like you're only ever going to have one set of dialogue sounds as far as I'm concerned with, like, the design of this game. I don't really foresee it having multiple dialogue sounds going on at once, and this is just going to get added in, or added on top of whatever other sound is going on at the time. So once there's, like, background music, the way that we render it here in this function is going to change. But a lot of that, the data about how we compute the sound for dialogue is pretty much going to be the same, and it's going to be coming from one place here. And this is, again, why I chose not to use the callback method that SoCal provides, because then you have to guarantee that you're reading and writing to this stuff in a thread safe way. And I don't feel like figuring that out, because I only have 6 months to live. Okay, so that's how we do that dialogue sound thing. And then, so I guess I can talk a little bit more about just like the rendering, which is, again, using SoCal, and we're using this SoCal GL library. This all kind of started because I was messing around with this other library called Puggle. And this is actually kind of developed by the people who make the LV2 plugin format. I was looking into this library as kind of a solution for doing graphics on Linux, especially in the context of doing UIs for audio plugins. Would be for a separate project that I'm working on. But this is also just like a really easy library to use to initialize a window and get an OpenGL context. And so I was just kind of messing around with that. And this was kind of my first time doing anything with OpenGL, like directly. And the only way I really knew how to do it without writing shaders was by using these like immediate mode, like OpenGL like 1 or 1.1 or whatever, using those functions to actually render stuff on the screen. And so I figured out how to render like textured quads just using OpenGL 1 stuff. And then I remembered that SoCal has this SoCal GL library that'll do a lot of the same stuff, but it's, as far as I understand, it's an API on top of like a more modern way of doing things in OpenGL or in the other rendering backends that SoCal provides. Which, if you didn't know, SoCal can do, you could do SoCal Metal. However, I had a problem with this because we have to modify the build to link to Metal. And then when we do that, not getting any, we don't get the texture, and we don't get the frame around it. So I think you kind of have to like mess with the coordinate system or something. Like it doesn't just directly translate. There's no like translation going on under the hood, would be my guess. So I'm fine with just leaving it as OpenGL for now, because this is not going to be a game with a volumetric smoke and fire and physics-based blood and gore. Although, I mean, I'll think about it, I guess. I'll think about doing that, and I don't know. Let me know if I should not do that, but I think I'm gonna do it. Actually, I think there's gonna be physics-based blood and gore, and dismemberment and stuff. What was I saying? Yeah, we're using SoCal GL. We're pushing vertices just by calling functions. I don't maintain any vertex buffers of my own. I don't want to. Haven't written any shaders for this, which is nice. It's a really nice way of doing like basic 2D rendering, because you can just call draw rect like this and just push vertices like that. Or you can call, where is it? Draw, there's a push textured quad, where we provide a quad of vertices and a quad of UV coordinates. And we just push them like that. And that's it. And yeah, this rendering layer so far is really simple. I mean, 300 lines so far gets you, I haven't actually made like a basic wrapper for vertices and just doing quads, but because currently I don't have a need for that. Well, I do have, draw rect and fill rect and draw line. So we have some basic functions like that, and then we have text rendering in just, a few hundred lines. So that's been pretty nice to work with, and I think you can kind of get a decent amount of mileage as far as like doing primitive graphics that you don't need to really rely too much on, or you don't need to be too concerned with like performance. And I don't think that this, I'm just curious. Using 9% CPU. 12 thread, that can't be true. Okay, never mind. 15% CPU on OpenGL. I don't really know how this like scales on Mac OS. I know when I was running this on Linux, I was at like 0.5% CPU, and I don't know, using 45 meg. Yeah, that sounds about right. But I don't know. Who cares? So I don't want to say too much about the game just yet. The working title is Apartment B4. What I can say is the game does involve, a lot of dialogue, going around and talking to the different residents of like an apartment complex and getting to know things about them and their relationships with each other and what they think of each other, and trying to find some secrets about the building and about what you're doing there and what your goal is. It's not too fleshed out, but I have been writing some dialogue and thinking about how I would implement a dialogue system. So that's been a lot of fun, and hopefully we'll have some interesting updates soon.